Alright guys, this weekend's video is over reaction types. We have 5 different reaction types that we need to work with. There are more than this. We're not going to cover redox at this time. We'll cover it later on. So let's get ahead and start going over these. Alright, the first one we have is a combination. It's also known as a synthesis reaction because we're making something. We've seen several synthesis reactions up to this point. Probably the most famous that we've seen though is going to be H2 plus O2 yields H2O. So what we've done here is we've taken 2 different pieces and we've put it together and we've made one piece. Now we just got done covering balancing equations, so we know this isn't a balanced equation at this point. We can go ahead and balance it. It makes the reaction complete, but as far as the parts going, this is showing us that we have combination taking place. They're coming together. Okay? So H2 plus O2 yields H2O. So we took 2 pieces, made it one. They combined. Alright, the next one is a decomposition. So if I were to take this reaction that I had right here, this combination, and run it in reverse. H2O yields H2 plus O2. Okay? In that reaction, what happens is we take the one thing that we made in the combination reaction and we break it apart. We decompose it. So we start with the one thing, break it into tinier bits, and that's our decomposition reaction. Okay, some little bit funner ones here with the single replacement.
Yes, funner is a word.
Displacement. I'm going to take a little bit of time. I'm going to write this one out because it takes a little bit longer. We'll get right back at you. Alright, I'm back. I've got an equation right up here, at least half of the equation. It's lithium plus silver chloride yields blank. Now, it's a single replacement. That means I'm going to replace one thing in the equation. I also like to call this dance theory. Okay, so I'm going to take a little bit of liberty here. Lucas, this one is for you. Okay, Lucas, you go to the dance. You show up at the dance all by yourself. Okay, guess who walks in to the dance? You have Miley Cyrus, your wrecking ball Miley Cyrus, and Miley's boyfriend. Now, this is what's called reactivity. Some things are going to be more active than other things. Okay, now I'm going to go out there, step out on a limb, guess that whoever Miley is taking to the dance is probably going to be a cute little guy. Okay, girls are probably going to think he's pretty hunky. So when we get over on this side, is Miley going to choose to stay with her hunky boyfriend, or is Miley going to go and hang out with Lucas? Okay, I'm going to go out there, Lucas, you're a great looking guy as far as guys go, but I'm guessing that Miley is not going to hook up with Lucas over here. I'm guessing Miley's going to stay with her boyfriend. So in this case, we would call this no reaction. We would write it with an NR. That would not happen. Now, let's look at it just the opposite. Let's say now Lucas is AG. Lucas comes to the dance with Miley. Somehow he did like some Twitter thing and got Miley to come do the dance with him. She felt sorry for him. Okay. Then the hunky boyfriend was there. What is going to happen over here? In this case, Lucas is probably going to get kicked to the curb, and we're going to end up with LICL, a new couple, and AG. In that case, a reaction would take place. Now, for this reaction to take place and happen, for us to figure it out, we actually need what's called a reactivity series chart. I will give you one of those. You'll have one of those available to you at all times. You won't have to worry about that. Now, just real quick though, I know that lithium reacts with a lot of things. So if I look to my chart up top, I know lithium is an alkali metal. I know it reacts all the time. Silver, it doesn't react that much. It's going to be low on the reactivity series. So I could just do that really quick without looking at the chart. The chart is very helpful though. Okay, the next one is double replacement. Double displacement is what the other term for it is. I call this double date theory. All right. So, now, ladies, you're going to have to give me some freedom here on this one because I am speaking on a guy term. So I know how guys are. Yes, I'm married. That doesn't mean that I understand how women work, though. So, guys, you're on a date. You're going to go on this date with your buddy. Now, you're in the car going to wherever you're going, dinner and a movie. On the way there, your girlfriend is just telling you where you're going to eat. She's just grabbing your ear. And you're thinking, oh my goodness, this is terrible. I just want somebody that's going to talk about sports with me, somebody that's going to understand me, somebody that wants what I like. So you look back in the back seat, and your buddy's friend or date is pretty cool. She's back there, she's talking about the game, she's talking about eating this burger that you really like, she's talking about cool things that you like, and you really like that. You're thinking, hey, that's a pretty cool girl. Now, you don't want to infringe on your buddy's rights there, so you stay back, so it's good there. Okay, but now at the same time, your buddy's in the back seat thinking, man, all this girl does is talk about sports, she's kind of annoying to me, I really don't want a girl that talks about sports, I want somebody that's going to tell me how I need to be. So he's kind of annoyed by her. It's just not who he's into. It's not what type of girl that he likes. So he's thinking, well, I really like that girl up front, my buddy's girlfriend. She's up there talking, telling him what to do. I kind of want that. I need somebody that's going to take charge and tell me what I need to do. So what they end up doing, now we're going to look at this. This is our little boy in the situation. And our girls are the O and the CL. So what happens, I'm going to write my LI and my AG over here. And what happens in that situation is they figure, hey, let's go ahead and flip-flop there. So we become LICL and we become AGO. Now when we do those flips, it's very important that we don't forget about their charges. LI has a positive charge, CL has a negative. It's good to go. No charge change. Okay, AG has a 1 positive, O has a 2 negative, so I need AG2O. So that's our double date theory. That's our double displacement. We flip through on that one. Very important. Don't try to change both things at the same time because you just end up back where you were. Just change the nonmetals. That'll save you a lot of grief. Now, we also have, just like we had a reactivity series up there, down here we have what's called a solubility chart. In order for this to mingle, we have to put it in something. Generally it's going to be water. Sometimes it's a gas. So a lot of times on these, you will see them written as being AQ, which stands for aqueous. Okay, so if it's aqueous, that means it's in water. We mix it together, all the little particles mix together. And if actually a reaction takes place, we get something besides aqueous, solid or gas, even a liquid. If we get something that's besides aqueous, that means the reaction actually took place and eventually they got married, had kids, whatever. Okay, so we'll talk more about that when we get it. We'll actually see chemistry. You'll see a great lab on this. It's going to be your first real lab write-up. A lot of fun. Okay, the last type we have is going to be combustion. Now, we went over combustion when we talked about the pumpkin, but a combustion reaction is anything that has a fuel. Now, we're going to use CH4 as our fuel. Methane, it's the simplest hydrocarbon. It's awesome. Plus O2. Okay, we need our fuel. We need an oxygen source. Now, when I have here, I'm going to have my yield arrow. In the yield arrow, that's where we're going to add our heat. We're going to add our spark. If I'm adding heat, I'm going to represent that with the delta sign, the triangle. Every combustion reaction makes carbon dioxide gas and makes water vapor. Okay, very important. People really look at water vapor and say, well, water's not a gas. Water vapor is a gas. Incomplete combustion, I'm going to write it underneath just to show you it's not a part of the actual reaction. But in real life, this is actually what happens. A lot of times you end up with carbon monoxide. Okay. So it's important to remember that we get that in incomplete reactions, but as far as like real deal reactions, if we're talking about perfect world, everything working right, we don't end up with that. Okay, so those are reaction types. They will be useful the rest of the year. We need to know kind of which way the reaction is going. We will actually be making predictions on what things we're making, and that's going to be a real big step for us. So, hope you have a great weekend. We will see you on Monday.